Okay, welcome back to my channel. Please, if you have not visited the first topic on linear momentum, please do this favor. Check the topic in the description below. Now today we have conservation of linear momentum. Now before we start this topic, as usual, I need your motivation. If you have not subscribed to this channel, please hit the subscribe button, hit the thumbs up button to give me a like. That shows that you appreciate the work I'm doing here. Now let's go. Linear momentum. Now, law of conservation of linear momentum states very simple. It states that if there is no net force acting on a system of colliding bodies, momentum before collision is equal to momentum after collision. Or you can simply put it that in an isolated or closed system of colliding bodies, momentum is conserved. Now, this isolated system of colliding bodies it's a system where no net force, no net external force acts on that object. So, in other words, if there is no net force acting on a system of colliding bodies, momentum before collision becomes momentum after collision. Of course, you know that momentum, assuming there are two bodies, body A and body B. Now, before collision, this one has mass. It possesses mass A, and it has speed A also. This one has mass B, and it has speed V. So, assuming before collision, the two of them are moving. After collision, it's either they jam together and move with a particular speed. So, in other words, we can now have that MA plus MA VA plus MB VB. So, this is momentum before collision. So, we said if that law of conservation is obeyed, momentum before collision is equal to momentum after collision. So after collision, two of them will now jam together. They will stick together and move with a particular speed. So this is momentum before collision. This is momentum after collision. Now, there are 4 cases that I want us to review now. If we review those 4 cases, then it can help us in every calculation we are making. Now, case 1, let us look at case 1. Case 1 is if the two bodies A and B, assuming, let me bring them together. Assuming these two bodies A and B, we have before collision and we have after collision. Now, assuming before collision, two of them are moving in the same direction before collision. These two of them are moving in the same direction before collision. We now have that MA, this is MA, this is that is MB here and VB here. Because before collision, if they are moving in the same direction, that means this plus this. Now, after collision, two of them stick together. If two of them stick together, A and B, and move off, they will move off with a certain speed. So, in other words, since they are moving in the same direction, this A and B will still give us a positive. I want you to take note of these positive signs. So, we use positive here when the two bodies are moving in the same direction before collision. And here, after collision, when they still maintain the same direction after collision. So in other words, this is before collision, this is after collision. These 2 cases are the same. Now, they move with a certain speed. Now, that speed V will now give us, from here, if we make V the subject from here, we'll have MA VA plus MB VB all over. Now this one, the coefficient of V, which is MA plus MB. So this is the first equation. Now we look at case 2. Case 2, I will clean this and I will clean this also. In fact, let me clean all of this because yes, my interest is on sign. Now case 2 said, suppose the two bodies move in different directions before collision. And after collision, they stick together and move in one direction. Case 2. Before collision, they are moving differently. They are moving differently before collision. Before collision, they are moving differently in different direction. Now, after collision, they move in the same direction. Now, what do we do? That means before collision, let's say A is moving like this, and then B is okay, let's say they are moving in the opposite, that A is moving like this, this one is coming. Now this one that is moving in the negative direction will have negative here. In other words, before collision, MA will have, this is a MA, MB, before collision, moving with VA and VB. Now in this case now, this is A minus B, that is what it will be. So take note of this negative sign here. So this negative sign here, if before collision, they are moving in different directions before collision. Now remember, after collision, they maintain the same direction. They stick together and move off with a certain speed. So in other words, before collision, here I will have negative sign here. Because I have negative sign there, I will also have negative sign here. And after collision, I will have positive sign here. So this is my equation 2, or let me write it out. So the second equation will give us MAVA minus MBVB all over MA plus MB. So this is my second equation. This is when they are moving in different direction before collision, and after collision, they maintain the same direction. Let us look at case 3. Case 3, if before collision they are moving in different directions, and after collision they move in different directions also. Now if they move in different directions, after we have treated this one, which is this. Now after collision they move in different directions. They move in different directions. This one like this one like this. Because of this one that is moving in the negative direction, this one becomes a negative. So in other words, I will now have V is equal to MAVA minus, remember before collision they are moving in different directions, minus MBVB all over MA. Now after collision now they move in different directions, minus MB. So this is the third equation. Now the last but not the least, case 4. Let's look at before collision, those two bodies are moving in the same direction. Now, after collision, they move in different direction. After collision, so before collision, they are moving in different direction, which is a minus here. Now, after collision, you see them move in different direction. We now have V is equal to MAVA plus MBVB all over. Now, because they are moving in different directions, after collision, we have MA minus MB. Now, these 4 equations, we can use any of these 4 equations. Take a look at them. Plus or plus that, meaning that before collision, they are moving in the same direction. After collision, they maintain the same direction. Now, minus and plus means they are moving in different direction before collision here. After collision, they move in the same direction. Now here, they are moving in different direction before collision. After collision, they still moved in different direction. This one, before collision, they are moving in the same direction, and after collision, they move in different direction. These are 4 different cases. Now, let us look at how to solve a problem using this. But then, I want to let you know that, yes, if a body is at rest, and a moving body hits it, let's take, for example, if A is at rest, and then another body, let's say if B is moving and hits A that is at rest, the implication is that before collision, they are moving in the same direction. That is the implication. Before collision, they are moving in the same direction. Now, after collision, it's either B pushes A away, or B will retrace its path. Okay. Now, let us take 1 or 2 calculations. Consider this first question. This question says, of course, this is example 1. An object of mass 2 kg moving with a speed of 3 meters per second head on with another object of mass 1 kg moving with a speed of 4 meters per second. If the 2 objects stick together after collision, calculate their common speed. And of course, this question came out in May, June 2018. Now, solution. Now, we have this is body A and this is body B. Now, the mass of object A is 2 kg. It is moving with a speed, that means the velocity of A is 3 meters per second. Head on, for 2 bodies to head on, that means this one must be moving in this direction and then B must be moving in the opposite direction. So this is the key word. The key word there is head on. So when they head on, that means they are moving before collision. They're moving in the opposite direction, please. Now, after collision, the 2 bodies stick together, A and B, and move off. Since they move off, we have MA and MB. They are moving with a common speed. So in other words, before collision, those 2 bodies are moving in the opposite direction. Now they say if they stick together and move after collision, that means after collision, 2 of them have now moved together in one direction. That means before collision, different directions. After collision, in one direction. Therefore, so we have that MB is 1 kg, while VB is 4 meters per second. So in other words, final velocity will give us, since before collision they are moving in different directions, negative, we have MAVA minus MBVB all over MA, because the 2 of them are together moving with the same speed, we have plus here, MB. If we substitute into this equation, we have MA will give us 2 kg, VA 3, that means 2 times 3 minus 1 times 4 all over MA. MA is 2, MB is 1, that means 2 plus 1, which will give us that V is equal to 6. 2 times 3 is 6, minus 1 times 4, 4, all over 2 plus 1, 3, which will give us 6 minus 4 will give us 2. 2 over 3, which will give us 2 over 3 will give us 0.67 meters per second. So this is the common speed with which the 2 bodies move off after the impact. Now we'll take the second question. This question says a body of mass 2 kg moving with a speed of 5 meters per second collides with a stationary body of mass 0.5 kg. If the two bodies move together after impact, calculate the magnitude of their common speed. Now, this is another scenario where we have the first mass is 2 kg. Now, the speed VA is 5 meters per second. Now, the second mass here, MB, the mass is 0.5 kg. Because it is stationary, the velocity is 0. So we have that velocity of object B is 0. Now, this is the scenario here. Let's say A is moving, B is at rest. Now, if A hits A, if A hits B, and at the end of the day, two of them stick together. Now, since they stick together and move with common speed, here will be plus, here will also be plus, because before collision, it is assumed that they are moving in the same direction because B is at rest. So we now have that their common speed V is MAVA. You put this plus sign here, MBVB all over mass of A and B, MA plus MB. Do not mistake A minus for plus when you are supposed to put a plus, please. Or when you're supposed to put minus. When you're supposed to put minus, put plus. Now V, if we substitute there, will now give us MA 2 times 5 plus MB 0.5 multiplied by VB. VB, remember VB, because B is at rest, velocity there is 0. All over mass of A 2 plus mass of B 0.5, which will give us 2 times 5 is 10 plus 0.5 times 0 is 0. All over this will give us 2.5. Therefore, V will give us 10 over 2.5 will give us 10 over 2.5 will give us 4 meters per second. So the velocity with which those two bodies move off after impact is 4 meters per second. There are questions, please. For more questions, feel free to chat me up in my private line. At any time, I will be able to help you. If you have not subscribed to this channel, please, I need your motivation. Hit the subscribe button, then hit the like button. Tell me how you feel about these lessons in the comment section, and I will be glad to respond to you. Thank you very much. See you in my next lesson.